Welcome to Los Angeles, the birthplace of Hollywood and the movie stars, and the center of the aerospace industry. LA's perfect blend of art and technology attracts dreamers from around the world. New York, Chicago, London, Paris. Every city represents its art, culture, and technology through its skyline. Buildings are the supreme blending of imagination and engineering. When you look at this spectacular building, remember that every building starts as a dream. High-rise buildings depend on the collaboration of thousands of professionals. They often cost billions of dollars and can take 5 to 20 years to build from planning to completion. It begins with a developer and an idea. Take the Empire State Building. It was conceived as the tallest building of its day by John Jacob Rascom, an executive with DuPont and General Motors. The Wilshire Grand Center was also envisioned by a businessman, Chairman Cho of Korean Airlines, who was introduced to Christopher Martin. Since its foundation in 1906, A.C. Martin has designed much of the LA downtown skyline. The trust and friendship the two chairmen had developed through previous projects were the backbone for their collaboration on a much more complex enterprise.
The organization A.C. Martin Partners is a 110-year-old company that found its roots in architecture and engineering with my grandfather, Albert C. Martin Sr., who was both a structural engineer and an architect. Started this company in 1906. Went on to the second generation of his two sons, Al Martin, architect, J. Edward Martin, my father, a structural engineer. In the third generation, David Martin, my cousin, was the designer, and I am the architect and CEO, business type.
I think you know that I am from a family of architects. I am the third generation architect. Grandfather and my father were architects, and so in a way, I was born into the profession, but also it was something I really enjoyed from a very young age.
The project is very personal, and it's a wonderful personal commitment to Chairman Cho and his family, who are absolutely incredible people. Chairman Cho grew up in war-torn Korea. He loved America. And here he is leading one of the great companies in South Korea.
Our chairman has a long relationship with Los Angeles. You know, he went to USC before and all that.
My initial start on the Wilshire Grand with Chairman Cho was a simple question. He said, what do I do with this old hotel on the corner of Wilshire and Figueroa?
The building is quite old. The actual opening was in 1952, and there are a lot of things within the building going wrong.
We said you could just demo the whole thing and then re-entitle it for its highest and best use, and that would probably be several million square feet, and it would be a very modern hotel and a modern office building. And he responded to that immediately, and he said, that's what I want to do.
During its 60 years here at Figueroa in Wilshire, the 16-story hotel played host to Pope John Paul II and Presidents Eisenhower and Kennedy. Now it's coming down. It'll be replaced by a 70-story hotel and office complex. It's estimated this project will create 11,000 jobs.
Chairman Cho is making an investment in Los Angeles, and he is personally involved in every single decision.
It was in 1950 when the Soviet Union and China supported communist North Korea to take control of the Korean peninsula. The Korean War started with the invasion of South Korea. To stop communism, the United States backed South Korea.
President Truman, while leaving open the door for Korean peace talks, warns against long-range Soviet aims and calls for vigilance as the price of peace.
Our constant aim in Korea has been peace, under the principles of the United Nations. Now, at last, the communist leaders have offered to confer about an armistice. This evil propaganda attack we cannot overcome with military weapons. The only weapons against such enemies are truth and fair dealing.
Because the two countries never made peace, this unsettling national divide has prompted thousands of Koreans to leave and start a new life in the United States.
This is going to be the first major building that any Korean company is building. And LA is the second largest Korean community outside of Korea. The Wilshire Grand Center is the symbol of Korea. Chairman wanted to have this building nothing short than fantastic.
High-rise buildings stand at the intersection of art and science. But unlike works of art, they are also made to be functional and rely equally on the creativity of architects and the mathematical minds of engineers. The Wilshire Grand initiated a high-rise design concept unlike any in downtown Los Angeles. An 1,100-foot glass-clad tower topped with a 3-story hotel and a roof shaped like a sail.
We wanted to build a building that stood out in a world of global buildings. When we realized how tall it would be and that we had the opportunity to create a skyline, we had inspiration pictures pinned up all over the studio. They were airplane wings, they were half dome. We all have been, Wyatt, Joe, Chris, myself, we've all been traveling to Yosemite together and see those mountains. I think that's kind of a mechanical and yet natural inspiration. This is a very crude diagram of, this represents a mountain, kind of the tower. The river is this idea of the architecture flowing, and then the rock. The implication would be that this may be made out of glass or something reflective. This river would be this undulating form, and the rock would be the base of the building. Maybe that's made out of stone and granite. This is to the west. I was always imagining sunset and the tower kind of melding into the sky. You can see that in a number of these studies. So this is one of the kind of a crazy drawing, sunset skyline, and starting to look at the flow of the form of the base, the tower, the spire is always in it. And then here's one of my favorites. This was July 2012, and that really, by that time, we had the fundamental kind of concept of what the building was going to be. All of the buildings that totally surround that building are made out of granite, and they're really representative of a period of time in Los Angeles. And we thought, not just to be different, but to give a vitality to the city and the skyline. An all-glass building would be very appropriate.
Designers want their buildings to connect to their environment. The glass exterior of the Wilshire Grand invites natural light into the tower and reflects its presence across the city's skyline. The Wilshire Grand was designed for Southern California's ideal climate. The translucent tower and podium function as indoor-outdoor spaces and contribute to the revival of downtown LA.
The idea of connecting this building to downtown Los Angeles was very important to us. A lot of buildings you just build out to the sidewalk and they could be very nice, but they don't make a contribution.
The city of Los Angeles wants to encourage high density in and around transit stations and in and around the urban center. So, corner of Wilshire and Figueroa is literally on top of the 7th Street Metro station.
This building has a number of ways to connect to the community. The most important way is I'll call it a piazza, but the plaza for public life. It should be very compelling when you got out of the subway as an attractive place where you would want to go.
Making the vision a reality is where structural engineers get involved. The architect's designs progress toward Brandau and Johnston's desks, the engineers of record. There, Gerard Nieblis and his team started the difficult task of turning creative concepts into constructible systems. A second structural engineer, Len Joseph of Thornton Tomasetti, joined forces with Brandau and Johnston to address the complex seismic engineering of the Wilshire Grand.
As a kid, I enjoyed building things. I got into using a lot of scrap cardboard and Scotch tape. We never had Scotch tape left in the house. It was always running out. Staples, things like that, to make things, to support my model trains, to develop jumps for my model toy cars, things like that. So I enjoyed very much the physical world. So our work basically was heavy duty up front, figuring out the right concept, the overall member sizes, the overall building behavior, confirming the building behaves well. And at that point, it was basically handed over to Brandau and Johnston, who would ask good questions of us, make sure they were comfortable with our approach.
From the time I was a little kid, I always loved to know how things worked and why things worked. And I just love being an engineer. I like solving problems, and the more difficult the problems are, the more I like them.
We did not make it simple for the structural engineers by any means. The overall form of the tower or the overall project is parametric in nature, doubly curved. And I have a sneaking suspicion that structural engineers like everything square. And that's not exactly what we handed to Brandau and Johnston and Thornton Tomasetti.
If engineers could determine what buildings would look like, they would all be boxes with no windows. Architects are on the other extreme. You know, they're always pushing the envelope. They want to get as much as they can for the budget that they have. This building is a 10. It's by far the most complicated building I've ever done. The geometry was just awful.
foundation is a critical element to any building. It supports the structure and transfers the loads to the soil below. Christ the Redeemer sits on a deep pile foundation system 2,300 feet above sea level. The deep piles anchor into the bedrock and prevent the statue from overturning, resisting all of the wind, hurricane forces, and earthquake loads. It's all about the view. But how do you get there? To create iconic monuments, engineers must conquer wind, water, treacherous terrain, and landslides with zero tolerance for mistakes. Like Cristo, high-rise buildings are traditionally constructed on deep piles. But the Wilshire Grand sits on an 18-foot mat slab that supports an 1,100-foot tower. Proportionally, this was a challenging choice, which at first sight defies common sense. The architects had to stack 2 million square feet, or 46 acres of commercial space, on a 1-acre postage stamp.
The very first thing that David and I and our engineering team struggled with was the slenderness of a hotel tower that was also going to be 1,000 feet tall. So, seismically active area like Southern California with a foundation that's going to be about 100 feet below grade, we needed a very large mat foundation.
Some trees have a very deep taproot, and that's how they stay standing. And other trees have a very wide net of shallower roots. In our case, we're more like that wide root system. We go up 73 stories, we go down about 8 stories, and then spread our load widely, reaching out beyond the edge of the building.
It's the size of a football field. It's about 270 feet long, 140 feet wide, 18 feet deep.
A mat foundation is a big block of concrete reinforced with steel. Concrete needs to be poured continuously to avoid cold joints that lead to cracking and disable the foundation. In the 1930s, the Hoover Dam utilized 3 million cubic yards of concrete poured continuously over 3 years. The Wilshire Grand created a foundation in just 17 hours that supports a 300 million pound structure.
We had to make 2,150 concrete truck deliveries. So we booked every concrete truck we could find. We were going to have to shut down all the streets in a 2-block area around downtown LA. In keeping with that, we had a party. We got the mayor and elected officials with the owner, Chairman Cho, and we came down the street leading a parade with the USC Trojan Marching Band.
21,200 cubic yards, which is a new Guinness World Records title. Congratulations.
Yes, today, right here, that record was broken, complete with recognition by Guinness. 18.5 hours of uninterrupted concrete.
This is LA's version of the concrete truck ballet.
And as the tallest building west of the Mississippi, it means people are betting big on Los Angeles.
That was probably one of the most exciting times. It was just incredible.
And the whole community embraced it. It was like watching a rock concert.
Murphy's Law is not just a saying, it's a fact. The 1906 San Francisco earthquake set off fires that burned across the city for weeks.
San Francisco, the scene of one of the worst disasters in the history of the country. A shambles of collapsed and blackened buildings.
It's amazing to visit the city with the highest real estate prices in North America, which sits directly on the San Andreas Fault, waiting for the next earthquake. The 1964 Great 9.2 Alaska earthquake remains the largest earthquake recorded in North America and the second largest earthquake ever recorded. produced a tsunami from the 4.5-minute event.
Soon after, the inevitable tidal wave came roaring in with the force of a dozen hurricanes.
That nearly wiped out the city of Anchorage. Entire streets collapsed and buildings toppled like dominoes. On January 17, 1995, Kobe, Japan was hit with a magnitude 6.7 earthquake. Large, high-rise buildings fractured and became inoperable. Kobe taught structural engineers that even a highly industrialized country with the latest earthquake design methods is at risk. Mistakes happen. Engineers have to learn from the past. Even today, the $600 million Millennium Tower in San Francisco is currently sinking due to soil settlement because the pile foundation did not reach bedrock. Murphy's Law or mistakes?
Police in Miami say that at least 6 people are dead after that pedestrian bridge collapsed at Florida International University.
Now, the cruel irony here is that this bridge was built, it was designed for the safety of FIU students. The 950-ton bridge was designed to give students a safe way to cross the busy highway below after the death of a student last year. The structure was just installed last Saturday.
Engineering is a trial and error process. The Wilshire Grand team is the accumulated knowledge of centuries of previous experience to prevent these mistakes from being repeated.
We pulled a foundation-only permit, so we didn't have the superstructure designed, and we started building the building. It wasn't until later that we found out that the seismicity at this site is probably about 25 to 35% worse than any other site in downtown LA. There's a fault directly below the building, about 1,000 feet.
Los Angeles is the land of the infamous San Andreas Fault. It stands at the crossroads of 2 tectonic plates, the Pacific Plate moving north and the North American Plate moving south. At this epicenter is a city of 10 million people. Everyone in LA lives within 5 miles of an earthquake fault.
People ask, where is the biggest demand in an earthquake? Where's the worst load? Everyone thinks the Hollywood picture of an earthquake failure is the building topples over. That's usually not what is a problem in a real big earthquake. Because at the same time that the building does do the swaying like this, it also has higher modes where things are wiggling along the way, and my fingers don't have that many joints. But these kinds of higher modes also interact and can create large shears, which is like the force this way, at any floor up and down the building.
We were fighting 2 things. We were trying to get a building that was stiff enough for wind design and a building that was strong enough for seismic. So by making the building too heavy, it makes it better for wind, but it makes it worse for seismic.
A key part of designing a tall building like the Wilshire Grand is what's called performance-based design. So that means taking a computer model of your building and running it through a series of simulated earthquakes. When the ground shakes, all different vibrations travel up and down the building, and you'll be able to see all these behaviors in the model analysis. The speed is about 1/6 of real time, but you can see now the waves kind of traveling up the building. It's not a big old lateral one-way sway. You can see the top of the tower, the sail kind of jiggling a little bit. It's seeing more acceleration than at the bottom of the building. We've exaggerated or amplified the movements by a factor of 50. If we did it to accurate scale, it would look like nothing was happening at all. The real building will not move like this.
Designing for an earthquake is part engineering and part roulette. Structural engineers don't know when the next earthquake will hit, what its magnitude will be, how long it will last, or where it will hit. They do know that it will happen. They can only make assumptions based on previous earthquakes. The engineers of the Wilshire Grand spent many sleepless nights devising a structural system that could withstand the strongest earthquake and the highest wind load.
The decision was made based upon a lot of very good thought, that it was a concrete core with a steel frame. The advantage is that the concrete core would slow the sway of the building down in an earthquake.
In order to make the building stiffer, we had to put outrigger columns on the outside edges of the building and attach those columns with braces to the core wall so that we take the overturning out in the edges of the building instead of just under the footprint of the core wall.
The perimeter steel is steel columns filled with concrete. And then supporting, or rather balancing, the core against the perimeter frame are BRBs, buckling restraint braces. So this allows the building, which is very slender in one direction, to be able to take the wind loading and the seismic loading on a daily basis.
High-rise buildings are all concrete or all steel. Concrete is fire-resistant and can last hundreds of years. In 1889, French engineer Gustave Eiffel designed and built his all-steel tower, launching the world into the Iron Age, where steel would become king. It only took 2 years, 2 months, and 5 days to build the Eiffel Tower. Steel has the advantage of speed. Multiple floors are constructed simultaneously. Take a world tour and you will see that most tall buildings are made of steel. The Wilshire Grand is one of the few high-rises in the world to integrate concrete and steel.
Most buildings that have concrete cores, they don't attach bracing from the core to the steel structure.
When you integrate these two types of systems, you have this very complex assembly, knowing that the concrete will shrink as just a normal, natural process.
So over the next 100 years, that building at the core is going to be about 8 inches shorter. So we had to deal with all the forces that would be induced on the building from the bracing being attached to that core wall as it shrank.
That was the number one challenge in building tall, and how we addressed it was probably one of the most successful challenges on this job.
Over the course of a year, just, worked out a solution for that. And it was a combination of things. It was the buckling restraint braces. It was putting in shrinkage-reducing admixtures in the concrete. It was timing the way we attached the braces to the building during the construction of the project. And it was also doing something that's never been done before on a building, and that's pre-compressing the braces in the top of the building. We compressed them about 3/4 of an inch, and then we installed them into the building, and then they let the jacks go, and then it lifted up the floors from 70 all the way down to about 55. And at the top of the building, the floors came up about 1/2 of an inch.
And so the outside perimeter columns are currently in tension.
Yeah, all the outside building columns are they're in tension. They're hanging from the top of the building right now.
That was a real, very difficult and very ingenious process.
Human psychology has an innate need to display success, power, and prestige. And this psychology carries over into the structures we create. 5,000 years ago, the Egyptians started the race to the top when they built the pyramids of Giza. These were the high-rise buildings of their time. Little did they know, halfway around the world, other cultures were also satisfying this basic human need to build. Since then, many kingdoms, countries, governments, and impassioned individuals have tried to outbuild, outperform, and outdo each other. But there was a limit to how high they could go. For 4,900 years, most construction centered on using bricks from mud and stone masonry. Then, in the 1800s, the industrial age introduced iron, and our skylines changed forever. The time had come to break new ground. America entered the race to the top in the 1930s with the Chrysler Building. This crown lasted less than 12 months when the Empire State Building eclipsed it.
The amazing Empire State Building, tallest of New York structures and the tallest in the world. It rears its 103-story head 1,250 feet over the sidewalks below.
America continued to build higher and higher into the 1970s. At 1,383 feet, the World Trade Center held the title in 1973 for only a few months, until Chicago completed the Sears Tower. Now known as the Willis Tower, this held the title from 73 to 98. That was the year the Malaysian government built the Petronas Towers, standing at 1,483 feet. This structure remained the tallest for 6 years, until the Willis Tower took the title back by adding 2 large antenna spires that increased the height to 1,729 feet. Then the Burj Khalifa in Dubai surpassed them all at a whopping 2,722 feet, over 1/2 mile into the sky. This race is ongoing. Saudi Arabia is next in line, while they finish construction on the Jeddah Tower, expecting to top out at 3,281 feet. Unfortunately, on September 11, 2001, the World Trade Center fell. "15 years later, it was reinvented and rebuilt to become the 4th tallest building in the world, the One World Trade Center. America's statement to the world that we stand united for freedom and liberty. Every country aspires to the sky. Engineers are designing new technologies to satisfy the appetites of creative architects and developers that want their buildings to surpass the current limits. Reaching heights beyond 2,500 feet is complicated by weight, height to width ratio, and overall cost. These soaring heights will continue to grow as new material develops. In the 1960s, the aerospace industry developed a new material that was high strength and low weight: composites. Composites have been used in military aircraft and recently in the Boeing 777 to make the planes lighter and stronger. High-rise buildings will be utilizing such technologies in the future, structures that will reach 1 mile high, and possibly new civilizations and buildings located on different planets. The race never ends. Although the Wilshire Grand is small by comparison, the fact that this incredibly slender tower sits above existing active earthquake faults deserves a place in the high-rise jewels of the world. It's not just a building. It's a sum total of many dreams. Certain iconic buildings carve their place in history through unique designs and innovative approaches. The Lotus Temple in New Delhi features a domed space of crisscrossing ribs with no columns. The structure is a lotus flower with 27 marble petals that does not contain a single straight line, an amazing feat for its engineers. In the 1960s, architects and engineers started experimenting with integrating structure into design. Chicago's Hancock Tower was built with a tapered design that exposed wind-engineered diagonal braces for the first time. In the spirit of creative evolution, the Wilshire Grand fully embraces this concept. Bell trusses and buckling restraint braces that hold up and balance the massive structure in an earthquake blend with lyrical design elements.
We wanted to pull that glass skin back and really show the muscles of the building. You know, Michelangelo and the Sistine Chapel, they have all these men and women, they're draped in these clothes, and then every once in a while Michelangelo will pull the skin back and you see this big muscle. We pulled the skin back and you see the big diagonal bracing. You come out of the 70th floor elevator into the hotel and you come through a forest of diagonal braces, almost like the Gothic kind of an experience. Tammy became the most trusted member of our team. It took about 2 meetings, and then any correspondence, anything they really wanted to know, they'd all go to Tammy.
When I go to certain meetings with people who don't know me necessarily, they'll never guess I'm the project director of the Wilshire Grand project at AC Martin until I open my mouth and you hear me like giving directions. When our design team designed that skylight in 2012, it was designed as a very light form and very lyrical form, and the reality is that it's a light form in the middle of 2 very solid, massive objects.
You know, there's the tower and the podium, and the skylight starts out in a valley shape, and then the valley shape kind of comes down to the plaza, and then it flips up. It is not only curving in 2 directions, but it's curving in a very dynamic way.
We took a look at the structure and like, how can we get this done and maintain this design and maintain the whole concept, the vision?
The solution to that was interesting.
I worked with John McDonald from Katina Engineers. He's really a specialist in these very inventive forms. And he took a look at it, and on day 1, I told him, John, we don't want to cut that skylight into 3 pieces. What can you do for this? He basically said, we're going to do drift joints. So you're not going to see it, but it'll be integral into the truss structures.
You think of glass as being very rigid. In that skylight, we've actually cold bent some of the glass. So some of the sheets of glass have actually been pulled down 1/2 inch, 3/4 of an inch to form into that curvilinear shape. Kind of an amazing, amazing feat. Maybe somebody's done something kind of like that before. Not in that shape, not in that form.
The tower reached 934 feet on March 8, 2016. To commemorate what had once seemed like an unreachable target, developers, designers, engineers, and construction workers signed their names on the last steel beam. It was approximately 4 years from the first truckload of concrete and a collaboration that involved over 10,000 people, 24 hours a day, 7 days a week. New York invented the modern-day skyline. The Chrysler Building started this trend in 1930 with its unique Art Deco style. Chicago extended the tradition with creative concrete and steel designs. Dubai has taken the lead in inventive high-rise design. Every high-rise here tries to outdo its neighbor. But Los Angeles has been a city of flat roofs. The Wilshire Grand is the first building on the LA skyline to break with this trend.
Downtown Los Angeles has a lot of flat-topped skyscrapers, and it's because they have a lot of helipads on the roofs. The Wilshire Grand design team chose to explore the options that were possible with modern fire protection technology and discuss this with the city, the building department, and the fire department. And in the end, we have a greatly reduced pad. It's called a tactical approach.
We worked very hard to work with the fire department to look for alternatives to the flat top helipad. So we did it, and then the next generation of high-rise, they're going to have the freedom. I feel good about starting that trend.
Originally, there was a spire, but it wasn't meant to go over the height of the next building to make it tallest building west of Chicago or Mississippi. That wasn't the original idea. During the course of this project, we joked about having the spire with a hydraulic system so that when the next building goes over our height, then we jack it up.
Any buildings throughout history, there's always some sense of verticality that connects man to the heavens and the inspiration above. Every movement needs to add up to being a beautiful expression of verticality. If this building was going to reach for the sky and be important in that way, one of the things you would think about is that the building would taper towards the sky, like a pyramid.
The top of the spire is 1,100 feet above mean street level, and that spire extends above the top of the sail, the crown sail on the building, about 185 feet.
Who knew we needed a corrosion expert, a fracture mechanics expert, a wind analysis 3 times, and 2 structural engineers to make that thing happen, and we redesigned it about 12 times.
And this whole thing came together as a real collaboration, young and old, experienced and less so. Quite a phenomenal piece of engineering and architecture.
This is frankly the star team. I've never seen a team quite like this.
You know, I can show my kids a building that I did, and they say, you know, my dad did that building.
Reminds me of something my father said. He said, David, this is a tough profession. It's really stressful and so on, but every once in a while you look back and you just say it's all worth it.
I am proud, very, very proud.
It's pretty cool to have something else, you know, that's completely different down here, especially from an architect's perspective, because we work in an architecture firm. It's cool to see something that's not just, you know, standard box.
We want them with pride to say, we're Angelinos. I want to go to the top of that. I'm going to use it. I'm going to have dinner there. They can say, honey, let's go downtown to the Wilshire Grand. We'll go to the top, take our friends, and have a glass of wine.
From watercolor sketches to complex structural models, the Wilshire Grand Center made the impossible possible. It launches a new era for developers, designers, and engineers to reinvent the Los Angeles skyline. This dream did come true.